Okay, so let's look at the scenario. If you were to guess at every question, what's the probability that you get 4 questions correct on a 5-question test? Can somebody tell me, so this is one of those combination 5, choose 5 would be getting all of them correct, right? So can somebody tell me what 5, choose 5 is? 1. What's 5, choose 4? What's 5, choose 3? What? No. 10. What's 5? How about this one? What's 5, choose 0?
1.
What's 5, choose 1?
5. That's 25. Or 15. The triangle thingy. Pascal's triangle.
Pascal's triangle. So that's been there all along, you just didn't know it.
I don't like it.
So check this out. So getting a question correct would be right, and getting a question wrong would be wrong, right? Correct? So if I wanted, and it's a 5-question test, so we have a right or a wrong answer. Okay, so which term would you need? You would need right being 4, right? 4 right, and how many wrong? 1. Which term would that be? The second one, right? Because wouldn't right being to the 5th power be the first term? So wouldn't that just be a 5 in front of it?
Go back. Rewind.
Some of you are understanding, don't worry, we're going to go through it extensively. But I'm just trying to see if some of you are saying, oh, it's the same thing. Okay, so check this out. I have this now for you. So R to the 5th would be 1 way to get all 5 questions right. R to the 4th, W to the 1 would be 5 ways to get 4 questions right and 1 question wrong. Are you seeing? It looks familiar. It should look familiar. Why should it look familiar, folks? It's a binomial expansion. Oh, you're going to love it in a second. Just give me a minute. It's a binomial expansion. What we've been doing the last couple days, it's been that way the whole time. You know, the only reason you guys didn't see the pattern is because you weren't putting it in your calculator individually. You're putting everything in your calculator and getting big answers. If you would have been putting things individually, you would have seen a pattern, right? Okay, so I'm going to show you 2 different ways. This one is this one fixed up. So 4 right, 1 wrong would be R to the 4th, W to the 1, correct? There's a 1 in 4 chance if it's a multiple choice, right? A, B, C, or D. So it's 1/4 chance to the 4th, 3/4 chances to get it wrong, right? Isn't there 3 out of 4 chances to get it wrong on a multiple choice? A, B, C, or D? It would be if it was A, B, C, D, or E. Then it would be 1 out of 5 and 4 out of 5. So the probability of it getting exactly 4 questions correct is 15 over 1024, or about 1.5%. All right, so a binomial experiment, that's what we call this. A binomial experiment exists if and only if all conditions occur. There are exactly 2 possible outcomes. 2 possible outcomes would be either right or wrong. Okay, what else? What types of other things we've been working with where you have 2 possible outcomes? Heads or tails, boys or girls, right? Things like that. Okay, there's a fixed number of trials, right? So for instance, this one, there's 5 trials. There's 5 different questions. The trials are independent. It's not like you take a penny out or you take a marble out and you don't put it back, right? That would be something different. And the probabilities for each trial are the same. No matter what, no matter which problem you're doing on a test, if it's a multiple choice, you've always got 1 in 4 chance of getting it correct. Yes? That's not going to change when you go to number 2, right? Okay. Let's work with this. I'll be able to find probabilities using binomial experiments. I'll be able to explain how to expand a binomial expression. All right. I'm going to do it 2 different ways. You get to choose however you want to do it. So just pencils down and eyes up. If a family has 4 children, I'm sorry? This is 12-9. No, it's 12-9. If a family has 4 children, what's the probability that they have 2 girls and 2 boys? Okay, so we have 2 different options, boy and girl. This would expand to what? 4. That expansion would be 1. The second one's always 4. Does anybody remember the third one? 6. 4. 1. You guys remember that, right? Then it would be, let's see, let's do this in red. This would be boy to the 4th, boy to the, boy to the, boy to the, boy to the, this one would be girl to the 0, girl to the 2, girl to the 3, girl to the 4. So which one do we need? 2 boys, 2 girls. So that would be 6, right? What's the probability of being a boy as opposed to a girl? What's the chance? 50-50, right? 1/2? 1/2 to the 2nd. And what's the chance of being a girl? Same thing, right? 1/2 to the 2nd. Which equals 6/1 times 1/4 times 1/4. Which equals, let's see, this cancels. This with a 2 and a 3. So 3/8. Or about, I think it's 37.5%. Questions? Pretty easy, right, how it relates? Because it's, where did I get the 2 exponent? We said 2 girls or 2 boys. So if we were talking about, you mean here? Okay, maybe it'll make sense if I show you another way. See how this is boy squared, girl squared? Well, what's the probability of a boy? 1/2. What's the probability of a girl? It looks confusing because they're the same. Okay. Do you see that this and this is the same thing? And I'm just substituting the probability of a boy in there and the probability of a girl in there.
Should have made the 1/2. One length, 1/2 square.
That is a fabulous idea. I like it. Color coding. Brilliant. Does that help? You see it now? Still don't see it? How this right here is the same as this? I'm just substituting for the probability. Isn't that what we did last night?
Yeah.
Right? Didn't you put the probability in? This what should look familiar. What did we do last night? Combination. What would be this combination? How many choices do you have? 4. Choose what? 2. Then I put the probability of being a boy. No. To the 2nd. And then the probability of being a girl. It's the same thing that we've been doing. There's the combination right there. which is 6, which we know because of Pascal's, because now we realize that there is a relationship between the two. You may do either one. You may see 4, 2 and say, oh, I know that that's the third term in a binomial expansion. I just want to put it all together for you. Okay? No longer should you have to put that in a calculator. You should be able to say to yourself, I know that it goes 1, 4, then 6. That's 6. Okay? So this is the alternate view of looking at it. Alternate way to write. Okay, go ahead and copy that down. All right, let's move on. A report said that approximately 1 out of 6 cars sold in a certain year were green. Suppose a salesperson sells 7 cars per week. What is the probability that the salesperson will sell exactly 3 green cars? No. So, what kind of problem is this? Right? There's a probability of selling a green car as opposed to the probability of not. What's the probability of selling a green car? 1 out of 6, it says right here. 1 out of 6. So sold green would be 1 out of 6. So what would be not sold? What would be sold other color? 5 out of 6. There's your 2 probabilities. Okay? All right, I'm going to do it the combination way. So this would be 7, combination 7, because he sells 7 cars a week. Choose what? What is the probability that he will sell exactly 3 green cars? So 7, choose 3. What is the probability of selling a green car? 1/6 to the third times, what's the probability of not selling a green car? 5/6 to the fourth. 4 plus 3 makes 7. Right? Go ahead, wrap your head around it. You want me to expand it using binomial expansion? Okay. So what's always the first number? 1. Then the second one? 7. It would be 7, 21, 35. There's actually another 35 on this one. 21, 7, 1. If we want 3 green cars, so here's green. So this green would be to the 7, right? This green would be to the 6. This green would be to the 5, 4, 3. That's the one. That's the magic one right there, right? So what would the other be? Other to the 4. See how that matches that? So what do you think 7 choose 3 is? 35. See it all relating? See it now? Good. I see light bulbs going on. Interesting how they relate, huh? Okay. So that being said, we already know that by expanding this right now, we already know that this is 7 choose 3 is 35 over 1 times 1 over, what is 6 cubed?
Really?
216? 216 times. Now, most of you aren't going to want to do this work, but I'll tell you, it's laying the groundwork for later. When you have problems like, what's the probability of him selling 3 or more green cars? Then you got to do 3, 4, 5, 6, right? And now I've shown you that there's relationships, right? So you're going to have symmetry sometimes. You'll get it in a second. What's 5 to the 4th? That would be 25 squared, 625?
Yes.
Over 6 to the 4th. I have it here. What's 6 to the 4th? 1296. Equals 21875 over 2799936, or 7.8%. Based on the fact that he sells, probability of selling a green car is 1 out of 6. If he were to sell exactly 3 green cars in a week, when he normally sells 7, that would be a 7.8% chance. Okay, make sure you have that written down. Okay, so I've got one more to show you. What is the probability that this salesperson will sell at least 3 green cars in a week? Probability of 3 plus probability of 4 plus probability of 5 plus probability of 6 plus probability of 7. You just made me mess up, Evan.
Sorry.
Distracting me with your hand. What's an easier way to do this? 1 minus probability of 0 minus probability of 1 minus probability of 2. Shush.
Yeah, I'm not blocking there. This one does it.
No. Mind is like a parachute, Evan. It only works when it's open. Well, you need to open it up, because the more you say you can't, you're not going to be able to. You don't understand. I need you guys to stop talking. Does everybody understand that 0 plus 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 will all equal 1?
No.
So if you, 100% probability
Okay, percent what?
is 1, right? On a scale of 0 to 1 is the same as the scale of 0% to 100%. So if I want to know these, I could just subtract the ones I don't want. What was the example of yesterday? The what? The soda. If I want to say what kind of sodas that I don't like, no. If there's like 12 that you like, wouldn't it be easier to talk about the 2 that you don't like?
That was mine.
Yes, I love it. Right, Evan? So it's easier to subtract the ones we don't want from 1, rather than add the ones that we do want. Is it? It's getting there? Okay, moving on. So I have 1 minus, what's the probability of 0? C. 7, choose 0 times the probability of getting a green car to the 0, not getting a green car to the 7, minus C, 7, choose how many? 1 times the probability of getting a green car to the 1 times the probability of not getting a green car to the 6, minus C to the 7, comma 2. Erase this. Times the probability of getting a green car to the 2 times the probability of not getting a green car to the 6. Well, if you know, this is 1, 7, what's the next number? 21. There's that right there.
I like it.
You like it now? It just clicked, right? Just clicked for you? So have a copy of the Pascal's triangle next to you and just use that.
Yeah.
Yep. You can make your own. If you can make your own, you can do it. No.
Wait.
It is not the same thing.
You have to have it memorized to use it.
You have to know how to derive it.
It's just a one. Literally all you have to do is know those.
Okay.
Wait, I'm sorry.
I already hit it.
1, 6, and 5, 6.
Was we from the previous example,
Oh.
right? I didn't make it up. Okay. So 1 minus, we know that that's 1. We know 1 to the 6. Okay, check this out. Isn't 1 to the 0, 1, and 6 to the 0, 1? So I don't really need that. I just need 5 to the 7th, which is 78,125 over, I'm going to show you exactly why you should write these out because they will help you later on. Because you'll have problems that relate to each other, and then you won't have to keep using your calculator. And then we've all seen that calculator with you doesn't always work 100%, right? Okay. So what's 7 choose 1? So you want me to put a parenthesis around this? How's that? Brackets work? Okay. All right, so the next one would be 7 choose 1, which is 7, right? Because we know that's the next term in the binomial expansion to the degree of 7. Times, isn't this 1 to the 1 and 6 to the 1? Wasn't this 6 to the 5? What's 6 to the 1 and 6 to the 6? Sorry, it should be 6 to the 6. What's 6 to the 1 and 6 to the 6? 6 to the 7. Didn't we already find 6 to the 7? 2, 7, 9, comma, 9, 3, 6. They're all going to be the same denominator. Exactly. So you really only need to find 5 to the 7th, 5 to the 6th, right? Couldn't I just take this number and divide it by 5? Take one of the 5s out? True? Because 5 to the 7th is 5 times 5 times 5 times 5 times 5 times 5 times 5. Did I do that right? So if I wanted 1 less 5, wouldn't I just divide one of those 5s out?
Oh, yeah.
See how they're all related? Okay, that's really understanding math, not putting in a calculator going, enter! I got it! Hope it's right, right? So if I were to put that big number and I divided by 5 and I got error, wouldn't I know that it couldn't possibly be right? Because it would have to be a factor of 5, right? To get... No, that means Evan didn't put it in his calculator correctly. Okay, so what's this one? What is 78,125 divided by 5? 15,625. So what's the next one going to be? This is going to be 21. That's going to be divided by 5. What is it? Kevin's got it. 3,125 over that big number, 279,936. I hope I didn't lose you guys. Good. Connection. It's all about the connection. I'm not most teachers, Evan. Okay. So after everything's said and done, let's get rid of the little graphic here. You get 26,811. This isn't this isn't exact right now. 20, because they all have the same denominators, so you could compare them over 279,936, which is about 9.6% chance.
Oh, that is what I got. Yeah.
Did I get the wrong one on the last one? Did I copy the wrong thing? No, 7.8. That's right. Does that make sense? The previous was if he sold exactly 3 cars, that would be 7.8%. The probability of selling 3 or more, it doesn't increase very much, does it? Why? What? Because it's only a 1 in 6 chance that you're going to get a green car, right?
Green can be a really ugly color.
I thought they were talking about eco
No, they're talking about green cars. Green colored cars.
Want me a red color or black color?
I wanted to know, I mean, guys kind of pull up the property and throw up a big green car.
Stop the wrong cars.
That'll throw people off. Okay, do I need to keep this on the screen for you?
Yes.
Yeah.
Okay, I'll let you guys have some time to copy. Okay, so why don't you guys try this one? If a family has 4 children, what's the probability to have 4 boys?
One Adam.
Alright, let's see how you guys did. Oh, I'm kind of surprised. Because the last class, nobody chose, I think there were 20 answers in, and nobody chose anything other than D. Okay, let's set it up. If a family has 4 children, choose 4. What is the probability they have 4 boys? 4. If this was a binomial expansion, what term would it be? The first term.
Because 0 girls.
Because 0 girls. So that would be, what's the chances of having a girl, I'm sorry, chances of having a boy? 1.5, 1 over a half to the 4th, because there's 4 boys, and having a girl is 1/2 as well, but there's no girl, 0.
So you're just looking at 1/2 to the 4th.
2 to the 4th. Yes.
Yeah.
1 to the 4th over 2 to the 4th, which is 16. The probability of having a boy. 1 out of 2.
How's that 1 out of 2?
Either a boy or a girl.
But you're having 4.
That's why it's to the 4th. The probability of being boy or girl is 1/2. It's a 50-50 shot.
There's no right in between.
It's not like boy, girl, animal.
Okay,
When?
try this one. I'm seeing if you got it so I can set you free on your homework. I just did a bunch with you. I need to see if you got what I did. Rather than me just do examples of your homework, that's just me doing more of what I just did. Let's see how you guys did. Better. Good, good, good. It's C. Alright, let's set it up. That would be choose. 7 cars. How many is he gonna sell that are green?
4.
4. What's the probability of selling a green car? 1/6 to the 4th. What's the probability of not selling a green car? 5 over 6 to the 3. Yes, sir. Okay, so 7 choose 4. If you put that in your calculator, what? You should get 35. Each one of these is 1 to the 4th, 6 to the 4th, 5 cubed, 6 cubed. But if you're multiplying straight across, let's get rid of this. If you're multiplying straight across, that would be 35 times, 1 to the 4th is always going to be 1. So the numerator is going to be 5 cubed, and the denominator is going to be 6 to the 7. And you're always going to have the denominator is going to be, because you're always going to have 4 and 3. If I were to say exactly 3 cars, it would be 3 and 4. That denominator would always be 6 or 7. If I were to say, what about 2 cars were green? That would be 2, that would be 5, that would be 7. Yes, sir. You count. You count down from 7. Because if I were to say successes plus failures, wouldn't that be S to the 7, F to the 0 first? Then S to the 6, F to the 1. It's the same idea. Make sense? Yeah? Okay, let's go to homework.
We got like
I didn't ask you how much time we had. I said let's go to homework. I want to...
Wait, last time we're going to
What did you learn today?
Binomial expansion.
Okay, so it's binomial experiments, right? But it's with binomial expansion. I can expand a binomial experiment using both what?
Pascal's triangle.
Pascal's triangle. Or you could use binomial theorem. You guys seeing that binomial theorem also relates now to combinations?
They have the first same name.
The same thing. All right, on your assignment sheet, expand the first 4 terms of the following.
What does it mean?
Let's apply. Can we expand that now? We know the first term is always going to be 1 times 2a to the what? 7. 4b to the 0. Plus, what's the next term? Next coefficient, I mean.
1 plus
7. 2a to the what? 6. And 4b to the first. See how much easier this is now than when you guys did it? Plus, what's the next coefficient? 21. 2a to the what? 5th. 4b to the 2nd. And the last one? No, not the real last one. The 4th one. 35. With 2a to the 4th. And 4b to the 3rd. That's as far as I want you to go. I said expand the first 4 terms. Good job, guys.